Alright, hello, welcome back to kottefolket game dev log. So, I think last time we did some random stuff like these things here. We fixed, we added some telegraph attack to the attacks of stening and swamping when they jump and shoot this guy. I made it so that when you hit something to stun, you deal extra damage. And now we can also see like how much damage you're doing, but it's only like a debug text, so it's not supposed to be there in the end, but it's just nice to see what we actually deal in damage. So it's correct. Yeah, and I changed the placing of this monster here. So that's basically what we did yesterday, I believe. There might be more things there, but yeah, we made some animations and stuff. But today it's gonna be probably kind of short. It depends on how much time this is gonna take, but I think I wanna solve this bug here. So I showed this yesterday a little bit, but essentially it's kind of hard to show without trying a whole bunch. But essentially, if I go in here, and you can kind of wall jump is the issue. Let's see if I can get one here. I'm gonna get rid of this one first here. So if you land just right, you don't even need to land like you don't need to kind of, you just need to push against the wall. And sometimes you get stuck. Okay, I have trouble actually showing this right now, but it's because you have like there's like subpixels. So the position is actually, it's a floating point number. And so it has like a lot of, variation to it. I think you have to be like almost exactly at the right position to get this. But anyway, there is a bug. I'm having trouble showing it now. Oops. Yeah. Anyway, there is a bug there. Oh, there we go. I got it. What if I do this? No. Okay. Anyway, you saw it, right? So, yeah, that's the bug I wanted to do. Sometimes you get stuck between the tiles, and that could happen in any direction. So that could happen in a wall. It could also happen when you just walk, and sometimes you kind of stumble or get stuck in between the tiles. And essentially, it's just because when you have like a angled velocity downwards, sometimes the tile in front will take precedence to stop you, because you're colliding with that first, and that will cause the X position to kind of stop. I think that one thing that we could do for the X position here is to kind of have an automatic, like let's say you're like 1 pixel off to actually reach the platform. Let's say if you're 1 pixel off, you could actually go into the next, kind of like if you had a slope like this, and like each step is like 1 pixel. So let's say, but we're not going to have slopes in the game, but I'm just doing this to demonstrate the algorithm. So basically, if you had a slope like this with 1 pixel each step, then if you move here, it makes sense if we would want to move up this slope, right? So in order to do that, we have to kind of check, okay, we're colliding against something, but can we move like 1 pixel up? Are we still colliding then? If we're not, then we should just be able to kind of move up onto that thing, right? So I think that should solve the issue when you're just walking along this tile, because then the difference will be very, very tiny in depth of that specific thing. Actually, that could be a general solution, actually. I mean, yeah, that could actually be a general solution. It would also allow you to, if you're slightly off, jumping up into a ceiling, like a corner like this, it will auto adjust to, you know, auto adjust you into jump up in the middle here, depending on how far you're going in there. So that could actually be something that we could do, and that will also solve this issue, I think. Will it solve this issue here? Yeah, I think so. I think it will solve this issue here. We'll see. Maybe there are gonna be other issues with that. I'm not sure. No, how would it... The other question then is like, how would we know if it's the X position or the Y? Like, if it's the X or the Y that we need to kind of ignore. I guess it's like if they are small enough, there's not gonna be a collision, but we also need to resolve it though. See, I got it there, but kind of put away. So, okay, what I'm gonna do is I'm going to do some search on the web if people have solved this problem before. Yeah, and another solution that I thought of was maybe you could merge the tiles so that we don't, like you before we check for collision, we merge all the tiles that can be merged. Although that could create a bunch of different special cases, which because then you wouldn't collide against each cell, you would collide against the whole row of cells at the same time, as like one rectangle instead, or a vertical column as well. But then the question is, like, how would that algorithm work? So I'm gonna bring up the browser here, and let's let's see, grid spatial hash collision detection. I mean, I guess we could just look for these. Also, this is a very simple, the kind of grid hash collision detection I have is very, very simple. It's like, it's a grid and each cell can only be either solid or not solid. So essentially you have a bunch of squares that can be either solid or not solid. %90 of your time is spent in 10% of your code. Okay, so choosing the proper algorithms for that 10% of the code in your game can be key. I mean, also to make it properly optimized and have it actually work. In collision detection and other performance-heavy systems, an efficient broad phase algorithm is also essential for real-time gameplay with many moving objects. Okay, yeah. Collision detection, broad phase. Yeah, so this one is pretty simple, I would say. But this is showing like a sweeping algorithm. Okay, this is the sweep algorithm. Yeah, so the idea with the broad phase is essentially you have a broad phase where you collect potential candidates for collision before, like, let's say you have a bunch of very complex bodies, like they could be polygons or something like that. You wouldn't want to check each polygon against each other polygon, you know, because then it would take a lot of time. So what you do then instead is you kind of make a box, draw a box around the polygon, and then have this what's called an axis aligned box, boundary box, which is these things here. So they all need to be the same alignment, which means they should have the same rotation. So they shouldn't be like off, like rotated like this. They should all have the same rotation, but they could be some kind of rectangle, because then those kinds of objects are very easy to check if they collide, if they potentially collide or not, or if they actually collide or not. So here you have this is colliding with the blue, but if you have more complex bodies underneath, we don't know if they actually do collide or not, but we do know that these two need to be checked against each other. And then we continue here, so we know that the yellow does not collide with these two, and the green does not collide with anything. So, and the yellow does not collide with anything. So we don't even need to check these. So we're basically culling a bunch of objects from being checked for the more detailed collision detection algorithm, which speeds up things a lot. So that is what's happening with this collision detection broad phase. Now, for my specific example, my specific game, I don't actually have complex things. I don't have rotation. So I only deal with these axis aligned boundary boxes. So the collision detection for me is pretty quick. I do have a way, because I have like a quad tree and stuff, to be able to check if a circle collides, or a line or a point or something else collides as well. But anyway, this is the sweep algorithm. I'm not going to explain this right now, but that's a broad phase that could be used. Then we have spatial indexing algorithm. Spatial indexing algorithm, this is what I'm using for the tile maps. Focus on finding objects based on positional queries, much like how a database uses an index to quickly find records based on a search query. To use a spatial index as a collision detection broad phase, you run a query for each object to find other objects around it. Well, I'm just using it for the tiles, not for objects that I'm using a quad tree for. A good spatial index has many uses beyond just collision detection. AI will frequently query for nearby entities or use raycasts for line of sight. Oh, AI like in, I was thinking like, you know, agentic AI, but they're actually talking about like AI in like a game, like a monster or something, an enemy. Will frequently query nearby entities or use raycasts or line of sight checks when making behavioral decisions. I'm also doing that. One-time events such as explosions might occur. You need to efficiently find which objects are within that blast range. Another benefit is you can split up your moving stationary objects into separate indexes. The index of stationary objects only need to be updated when one was added, moved, or destroyed. Comparing this to a broad phase, which can give you pairs of colliding objects for one large list. Yeah. So the broad phase would be used for resolving collisions, because then everything needs to be checked for collision to physically collide with other things. And then the other would be for like special things happening in the game, like explosions or line of sight or stuff like that. That would be special queries for that thing. When working with spatial index, there are a few core operations. Insertion, removal, querying, and reindexing are the most important. Also, when using a spatial index for broadface, it's useful to combine reindexing and querying for all collisions into one operation. I think what I'm doing is I'm basically building the grid first. I'm building the grid because it's static, so it never actually changes. All dynamic stuff is in the quad tree, and that is actually rebuilt each frame. But the grid spatial hash is a static hash that's built when you kind of load the scene in. You can also, it could potentially just be pre-built, but it doesn't really take that long to build a thing. So it just goes through the entire tile map, it builds up the grids from that, making everything solid or not solid, and then you have a bunch of, now you have a grid of those, and we can now query this data. So then essentially every object that can collide with ground is then checked against this, is then queried against this, the static grid. So we don't need to be able to change the grid. So we don't need like insertion, removal, query. Like querying we need, but reindexing and stuff like that we don't really need. Okay, simple grids. Placing your game entities in a grid and natural easy way of indexing them. Visualize drawing grid over your world maps, 2D or 3D array. Each cell grid stores reference to shapes if the ABV of the shape intersects a grid cell. Tile maps can be thought of as a simple grid, although they usually have a single tile per grid cell. Yeah, that's what I have. In general, though, you can have many shapes overlapping a single grid cell, and a single shape can overlap many grid cells. While there are a lot of variations, grid algorithms will walk through one simple and flexible implementation. All right. Any game that takes place on a single screen or a fixed size map, your grid size matches the size of your world. The size of the cells within the grid should match the size of the objects in your game. The broad phase search becomes quite simple since you're just checking each cell for multiple objects. Okay, so I think what they have is like each cell has a reference to whatever is in the cell, maybe. We'll see. With a grid, you store lists of overlapping shapes into each cell, right? Oh, only overlapping shapes. Or all shapes that are overlapping the cell, right? The purple and orange grid cells show places where multiple shapes have been inserted into a cell. The shapes in these cells may be colliding and should be checked closer. So that's pretty cool, because then it's like database. It's like all of the cells that have more than one. So you just go through each cell and check, do they have more than one thing there? Then we need to go check those things against each other for collisions. Cool. Time for some pseudocode. Okay, but I'm not doing it like this because I have a separate thing for dynamic objects. So I'm actually just interested in like a static. Hello, Blue. What is that? This is a. So I'm going through. I'm trying to solve a bug for my with my grid spatial hash algorithm, and this is just showing. I'm reading an article here about spatial indexes and collision detection with that. So what they're showing here is essentially, this is the grid, right? These boxes here, each cell, this is a cell. And then you have a bunch of objects that are in here. So how they do it is that they actually insert the objects into the grid hash. I'm not actually doing that. I'm using a separate system for checking the dynamic objects. So what I'm doing is each cell can be either solid or not solid, which corresponds to a tile that is solid or not solid. And these objects then are checked against those. So, but I'm trying to dig out the information that I need from this article to see if we can solve this issue here. Instead of storing reference to objects directly in the grid array, we're creating proxies. We'll perform a simple retain counting on these and keep a stamp to avoid duplicate results when querying. The results for this will be explained later. Right, let's start with the code for insert operation. They said this was pseudocode, but it looks a lot like C or something. But anyway, let's see. Let's see here. So, okay, this is insert, so we don't really care about this. Removal, yeah, we don't care about that either. Well, there are a number of queries. So this is a query. Well, there are a number of queries you want to implement. Point line, AB, etc. Yeah, the AB query is good starting place. Much of it should look familiar. Okay, so this is a query. So this is essentially what I'm doing. I'm basically giving it an ABB, and then I'm querying against the cells. So the thing is here, though. The thing is here. I wish they would go through then how a tile map would play into this, because that is how. That is what I need to solve. I'm still thinking about the first solution to the problem that I was thinking about, if that actually works or not. Yeah, we could try it, but let's go through here first. Okay, so this is the query. I'm guessing this is just gonna go through the things that are in the cell. The cell itself, like, it can't be solid or not solid or something like that. It just has a bunch of objects in it, and then we're checking collision against those objects. So let's see. It's like query stamp. Okay, so that's like an ID for the query or something. I don't know. Convert the object's ABB to integer grid coordinates. Okay. Proxies in cell. Oh, so each one is like a list. And we're going through each list of things. We get the object. Check that the proxy hasn't already been processed by this query and neighboring cell. Oh, I see. So it's like. Hang on. Query stamp not equal to hash query stamp. So we're modifying this query stamp for one query. Okay. It's a way to check if we have done this or not. I see. This is actually kind of cool because if you were using a bool for this, you would have to toggle the bool back afterwards. So you would have to kind of loop through everything again. This makes it so you don't have to do that. So that's actually pretty cool. Because I was like, what the hell is going on here? Like, but now I understand why. Also, the check that the proxy's object hasn't been removed. Okay. Okay, so we're checking if we haven't checked before, and if it's not equal to no, right? So then we can check Yeah, that's the callback for that. Okay, so that's just checking that. Okay, cool. Reindexing, I don't care about that. Lastly, it was mentioned that query operation is useful. What? This is easy enough to implement by performing a query. When was this written here? 2025? I was getting a little bit of AI vibes there. But okay. Performing a query immediately before inserting each object during reindexing operation. This way you'll never have an advanced grid-based index ease of efficiently running queries. Blah 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 blah. Couple problems. Yeah, I don't have an issue with this since my grids doesn't store the objects in them. And also, yeah, this is another issue. If you have like a lot of grids, a lot of cells with 5,000 objects inserted, if each object was inserted into 4 cells each, you would be using 2% of the cells. Okay, well, if you have a very sparse world, you would probably use a sparse hash instead, where you would have, I guess, like multiple islands, sort of. You wouldn't store the entire grid. Like if you want to have a large world, you wouldn't store probably the entire grid. You would only store the places that actually has anything in them, or something like that. There's probably other ways to do it as well. I don't know. Spatial hash. I think it feels like we've already been through this. Wait, spatial has a special type of grid index that uses memory more efficiently. Instead of creating a large multi-dimensional array, you create a small 1D array and then semi-randomly map the grid cells onto that array using a hashing function. Okay, so maybe I haven't been using a hash. Maybe I've been lying all this time because I didn't actually know what it is. But okay, this is interesting. A semi-randomly map the grid cells onto the array. This has a lot of benefits. You no longer need to think about grid bounds or size. Why, though? Any grid cell may be mapped onto the hash table, limited only by the size of your integer type. Okay, sparsely populated grids won't eat up your memory either. So it's a sparse. If the array is mostly empty, you can just make it smaller. This is also good for when you want to clear grid as a smaller array and can be cleared faster. The thing that I'm confused about is how, like, a lot of questions here, actually. There are a couple of minor downsides because many grid cells can be mapped onto the same array location. It's possible for 2 objects that are far away to be returned as a false positive bonus spatial hash, or it is fairly rare and could be quickly rejected by a bounding box check. Another issue is that it's possible for a single object to be inserted into the same array index more than once for 2 separate grid cells. You'll either need to catch this condition or make sure that you never assume that list of cell contains all unique entries. Yo, Penguin! What's up, what's up? Welcome back. How's it going? Yeah, I wish it would explain this more, because it's just like, okay, it semi-randomly maps the grid cells onto the array, but that would still use the same amount of memory, though, right? Because you have an array that is, I mean, I feel like it's not explaining this. How large is this array? I'm back after 3 days offline. Oh shit, we got power back. Wow. Did the power, like, Do you have? I mean, how do you? Like, what about food and stuff? Man, that's tough. Living like that, it's insane. What makes a good hashing function? A poor hashing function could result in uneven distribution of objects into the array, negating some of the benefits. On the other hand, the hashing function may easily be called hundreds of thousands of times per second, so it should be fairly efficient. Yeah, so if you're having 16, let's say you have 60 FPS, that's, or even 100 FPS, that's 10 frames. No, that's 100 frames per second, yes. That's 10 milliseconds, I think, per frame. 10 milliseconds per frame, and then you say you have, I don't know, 1,000 objects. Wait, the hashing function. What do you mean by the hashing function? In Chipmunk, I use the following hash function in conjunction with. Oh, Chipmunk. I think isn't that like a 2D or like a collision detection library? I use the following hash function in conjunction with prime-sized hash tables. This has proven to be this has proven to provide a reasonable level of performance. I'm confused. So you have x and y and table size. And then you have this thing happening here. Multiplying by large primes, XORing them together, and then modding by a prime table size makes a pretty good hash function. Prime table size. So is the prime table, is this also prime, or implementing the insert delete query index operation for a spatial hash are almost identical to a spatial hash? What? Implementing the insert delete query and reindex operations for a spatial hash are almost identical to a spatial hash. You can remove the min-max clamping when calculating the grid coordinates, as they are no longer needed to protect against array indexing errors. Instead of accessing the grid's array as a 2D array, you just need to swap in the hash function. Array size. Like, is that like width times the height, or the efficiency, or is that the 1D array size? I have no idea. The efficiency of the spatial hash and the simple grid. Alright, it's modded by this. So it's like if you have an array with array size, you're guaranteed to fit this in here, right? The efficiency of the spatial hash and simple grid depends on the grid cell size roughly matching the sizes of the shapes being put into it. The efficiency of the spatial hash and simple grid depends on the grid cell size roughly matching the size of shapes. Okay. If your grid cell is much smaller, each object will have from 7. Okay, yeah. Spatial hashes require an additional tuning parameter compared to single grid hash type. When working with a grid, you simply need to worry about making the dimension big enough to fit all your objects. Then tuning the cell size. With the spatial hash, you also must tune the size of the hash table itself. If the hash table size, like I still don't understand about this spatial hash. Like it feels like we just dipped our toes in some of the things regarding a spatial hash. It's like, yeah, just replace, let's just make this function, then replace this with this. And then you're done, or what? No, we still need to re-implement the other functions like insert and stuff. But this doesn't even tackle the issue that I had. So there we go. But we learned a little bit, I think. I know what spatial hash is now, so I maybe should stop calling my thing a hash, because it's not then, if this was correct. So maybe I'll remove hash and just have grid spatial collision detection. Oh, hey, AI has something for us. Grid spatial collision detection or spatial... I don't know, man. I have no idea. Spatial hashing. I mean, I guess it's a variant maybe then. It's saying that, hey, this works for spatial hashing as well. It's not saying that this is a synonym for this, right? Partitions a game world in a grid of uniform cells. Instead of checking every object against every other object, the system maps each entity to overlapping cells and only tests for collisions with other entities sharing the same cells. I wish there was, maybe there's a name for my specific case where you have a simple grid, maybe. Not sure. Partition space, assign objects, broad face check, choosing cell size, handling move objects. I'm gonna tell AI here. So my spatial grid hash is very simple. It simply contains the static tile map. So each tile is one corresponds to one cell. Each tile corresponds to one cell. Each cell can be either solid or not solid. The issue that I have is that collisions... Okay, actually I should explain this as well. Dynamic objects are then queried, or dynamic objects are then resolving their collision with the tiles by querying into the grid, into the spatial grid. Querying their AABBs into the spatial grid. Okay. The problem that I have is that if a dynamic object collides with multiple tiles, there is a chance that it gets it collides with both one in the x-axis and the other in the y-axis, or maybe, I think, which causes some bugs in my 2D platformer game, such as being able to wall jump sometimes, because you get stuck in between two tiles in the wall. How would you solve this issue? Okay, this is what's good about AI, because you can ask it very specific questions. And let's see if it makes any sense, this answer. We might get the same idea that I had, or we might get another idea, or we might get some bullshit. But we'll see. This is a classic problem in 2D tile-based platformers. It happens because you're likely resolving collisions multiple times at the same time, or a calculation pushes the player into the seam between two tiles, triggering an unintended wall collision. Yes. Or it's colliding for the bottom tile first, which corrects the X position or the Y position or the Y velocity to stop. And then it corrects the X as well. But then you're kind of stuck there because I guess you're facing into the wall. Huh. Maybe we should do multiple passes. I don't know. It's a bit tricky, I think. Well, we'll see here. Calculation pushes the player into here are three most effective ways to solve this issue, ordered from the cleanest architecture to easiest quick fix. Okay, solution 1. Axis. I'm gonna read the titles first. Solution 1 is axis separated resolution recommended. Okay, so you resolve for one axis at a time. I guess. Solution 2, filter by internal edge normals. Okay. Solution 3. I'm interested to know what this is. The Minkowski AB sort quick fix. Okay, so I am familiar with one Minkowski thing. I'm not sure if that's what we're talking about here, but it's like you outline a boundary box or something like a collision, like an edge. You take a shape and you move it around the edge to get a new shape that goes like a little bit outside to get something you can use to be able to check if something collides or not. If you query multiple tiles simultaneously and loop through them to resolve collisions, the order of resolution matters. If you resolve a tile further away first, you can push the player into worse position. Sort by distance. Sort the following colliding tiles by how close they are to the player's center before resolving them. I guess that makes sense. Sort by overlap depth. Alternatively, calculate the intersection depth for all colliding tiles. Resolve the tile with the deepest overlap first. After resolving in the deepest collision naturally fixes the position so that the second tile. Right, so what I'm worried about there is like some kind of weird edge case. But yeah. What is this? Summary checklist. Separate the axis, move X, fix X, move Y, fix Y. Wall jump logic. Only allow us a wall jump if X is actively pushing into the wall. Or check if the collision is strictly horizontal. If you'd like to implement one of these, let me know. I'm thinking about the problem. The problem is probably mostly the velocity reset. Like if you hit the ceiling, the velocity is set to 0. The velocity y is set to 0. If you hit a wall, velocity x is set to 0. The most robust fix for... Okay, let's look at this. Axis separated resolution. The most robust fix for time is split your move in the collision resolution in 2 different independent steps. Horizontal first, then vertical. Instead of moving the player, it just sounds like this could work, but then it also sounds like there's like edge cases where this doesn't work. I don't know. Like, why horizontal first and then vertical? Is it just because of yeah, whatever. Let's just read through this. Instead of moving the player by velocity x, velocity y all at once, do this. Apply x movement. Check and resolve x collisions. Okay, yeah. Set velocity x to 0. Then y. Okay, I see. Because this would solve the issue where you just move on top of a platform as well. Because you don't move down because of gravity yet. You move left or right first and then move down. Yeah. And if you're going into a wall, we're moving in X first. If you and that stops X, so that makes sense. And then Y is a separate thing. So now Y shouldn't collide anymore because you're on a wall. Yeah, and your velocity axis has, or your position has been resolved. Yeah. What about a ceiling? If you jump into the ceiling, you would actually move in the X as well. But that, I guess that's fine. Yeah, I guess this solves it. I mean, I don't really understand why this is the quick fix and then this is not a quick fix, because this seems like a very quick solution as well. Hello, Phil. Massey Cott. I'm not sure if I pronounced that correctly. Welcome back. How's it going? Okay, let's do this one then. By separating axes, a vertical wall tile will never accidentally resolve a horizontal condition, completely eliminating getting stuck in the seams bug. Okay, let's do this one. This seems like a very, very good fix here, actually. Whoops. I just maximized the window. Okay. And I have to go into the physics. I have to go into my game engine project. And here's where's the thing? The grid. Okay. So this is not a grid hash. I'm gonna call this a spatial grid instead. Spatial grid. There we go. I was misunderstanding that thing, because I was thinking the hash thing sometimes, you know, it's kind of weird because when people say a hash table, sometimes they just refer to a map from string to something else, right? So it's like it's just a normal map. It's a map from string to something. But hash also generally means, you know, the weird like random numbers and letters that is calculated from some other data. Anyway, yes, you got it right. Okay, cool. How's your project going? It's going good, I think. It's going good. I mean, as long as it's moving forward, it's going good. Right now I'm solving a bug for that allows you to kind of incorrectly wall jump and get stuck on the wall and stuff. Okay, so that's a spatial grid. Let's see where this is happening here. Intersections. Yeah, that's where we get the intersections. Get circle intersections. Let's see. This is these ones, get circle and get line. It's like these have been generated. I'm just gonna go ahead and admit that. 2 grid coordinates. Okay, check intersection. Where is this from? That's from there, okay. Okay, so this is happening here. So this function here is used to get all of the intersections. I need to think here. So this one is actually, so actually the resolution does, no, the resolution has to happen somewhere here. Yeah, this is where it's happening. So grid hash, yeah. Yeah, we get the intersections and then we get a bunch of collisions and then they are then resolved later. That's the thing now. Should we just do that for everything then? Because that's gonna get resolved. That's gonna get resolved later. In somewhere. I don't remember exactly where. Resolve. It's gonna be resolved over here. Okay. So I think essentially what's gonna happen then, maybe we need a different algorithm for resolving the collisions. Because this is only for one collision. And this is then used, this is used in the physics. Yeah. Resolve collisions. This goes through all the collisions, it resolves them. So I'm thinking maybe what this would be is that it would first go through every collision and resolve for one of the axes at a time. Is that could be the solution maybe. But that can't, yeah. Okay. It really changes how this is done though, because this is more like maths based here. Except the thing is, this is very special as well, because it's like, yeah, this is resolve collision static, so it's really, what if we added axis here? Wait. And I'm just gonna ignore the dynamic for this. Actually, you know what? What we're gonna do is if axis is x, we resolve. So that, but we actually resolve both. Y doesn't do anything because we already resolved everything. Okay. Now this is probably not a recommended way of doing things, but whatever. Okay. But then we go here and we say inline for tags of do we have this thing? I think it's over here. I think it's this one. No? Physics/collision. This one. Yeah. Okay. So we'll do for each axis, we'll do this. Oh shit, sorry. Thanks for telling me. Okay. Okay, yeah. So I made this axis, and for resolve collision static, we now have this axis. I've not implemented it here yet, but it's supposed to only be for one of the axes now. And then I'm going through each of the axis tags in this enum, which is x or y, and then we get that out here. What this actually will do, because it's an inline for, it's essentially copying this code for each member of this axis. So and you get like the first one will be x and the second one will be y. It's probably not the most efficient way of doing it. Like what we could do otherwise, if we could do like axes. How do you axes? How do you type multiple axes? And then, or is it axes? Axes, I don't know. So this would be a list of axes, and then we have like x and y, and now we can actually loop through those, so it doesn't like multiply. It doesn't copy, like multiply the code. You can do this as well, but then we don't actually go through each one. Although you could technically probably get these tags though, actually. Actually, couldn't we just do this without inline? Is this comp time known? I mean, I guess if it's comp time known, it doesn't actually matter. We could just loop through that normally, right? Yeah. So if you do inline, it's gonna copy the code. If you do not do inline, it's gonna create a loop, and this axis is gonna be an actual array here. Okay. I hope, at least that's how it works. Okay, so we need to actually implement this now. And let's see. Okay, so this is how the velocity and the position is changed. So we calculate the depth of intersection, go back times the normal. So we take the normal of the surface, we go back the depth. So that essentially goes out again, but it does it with both axes. So we don't do that. We have to say, let's say we just say this. So if the axis, let's just switch axes. If it's X, we set the position. I'm gonna fix this like later. Well, let's do this. So if it's X, then I'm gonna do init. Y is gonna stay the same, and X is going to be whatever this will provide as an X. So we could actually we could calculate this here. We could say correction is going to be normal times scalar depth, and this is then correction. And for y, it's going to be the opposite here. So we're going to have x from correction and y from position. Okay, so that is the position being corrected there. Then we have the velocity now. So velocity is also changed. Now, essentially what's going to happen is, because we're dealing with mass and stuff, mass is actually infinite. No, it's not infinite. It's infinite for the static body. This is the mass of the body. But if we calculate this, JA is the dot product relative V. So relative velocity, I mean the static doesn't actually have velocity. So the relative V is actually always negative velocity. And then we have like 1 plus E, and E is 0 because it's the restitution, which we always set to 0 in this case. We don't have any that there, I guess, right now. Because it fits our game basically. So E is 0. So essentially this is like, if I, let's actually make a, so this would be -1. And then that is dot product against the normal. So essentially I could just negate this here, negative. And since negative rel v is just v, we can also just replace this. So essentially it's the velocity dot product against the normal. So what you get is probably some kind of negative value because we're going against the normal. That is kind of how far, like the depth you get in, but only relative to, but like relative to this normal, I guess. So if it's on the left edge, you would get like the X depth. If it's on the top edge, you would get like the Y depth. So this corresponds to either the X or Y depth, whichever is, I guess, depending on the normal, which way it points. In this case, it only points to, you know, left, up, right, or down, because that's how our game is made for the static objects. So yeah, this essentially is like X depth or Y depth. And then we times it by the mass because of reasons. And then resolution is then the, actually this is the velocity. This is the then result velocity that we get. So we take velocity, and then this is the velocity correction. So this is the position correction, and then we have the velocity correction is normal times v scalar j over mass. Right, we take over mass. Okay. So essentially we don't need to worry about mass. Is the okay, so we can just remove mass because we times by mass here, and then we remove mass here. So this is just JA. I'm gonna actually go back. I'm gonna do this. Okay. So we have the original intact. Right. So that is V correction. Actually, we should probably negate it and then add instead of. Oh, I forgot about one thing, actually. This should be P plus correction. Yeah, there we go. I wish we could probably do directly here instead. Correct. We could, if we take P plus here, we can say that this is the corrected P. And we don't need to do P plus here. A little tiny bit more efficient. Okay, so that is the position. Here's the velocity. And I simply want to just say this is the velocity there. Okay. Cool. So essentially the velocity then is like whatever is like the depth of x or y depending on which side we're colliding on. So essentially this is going to be either x or y. But I think that if we do collide in either axis, which we are here, then we should also reset x or y. Actually, we don't know if we're actually colliding. We should check. Actually, yeah, we should check if this is then. Wait, hang on. The thing about this operation is we're kind of losing the axis here. I think. So rel v's we don't need. And we don't need the mass. And we don't need the. Okay. Because what we want is like if axis, like switch axis, if it's x, then we could check. We could do like axis dot normal. Wait, and then hang on. No. So essentially what we want to do is basically here we want to set velocity x to 0, but only if we collided on that side, I guess. Like if the normal is horizontal. If normal is horizontal. And then this one set y to 0 if normal is vertical, I think. So that should be 0, right? Because up is like 0 minus 1. Normal is either, it's one of the directions, right? So it could be up. If it's up or down, we should get a non-negative value. If it's left or right, we should get a negative, because then both, we're timesing it, so both should be 0. And then adding that, so that should be 0. So I'm gonna say, like, we only need to do this once. So I'm gonna say is horizontal, is saying that, or is vertical, if it's going like that. That's the only thing we need to do. So if it's horizontal, if it's vertical, if is vertical, if it's not vertical, x, velocity x should be 0. And y is the other way around. Thank you, Piano. Good luck to you as well. So y is set to 0 if it is vertical. Yeah, because then if you're walking along the ground and it's resolving the collision of the left, like if you're moving to the left, if it's, and you're standing in between two tiles with your left, with your foot, with your toes, it's dipping in between the two tiles. If you resolve the collision of the one of the tile in front of you first, and it's resolving for x only, so it's moving you in the x direction only. Oh shit, I forgot about that. Wait. Oh man, okay, this is actually way worse. Because we're moving the object in both directions and then getting these collisions. So we actually have to change a lot more, I just realized. Because we have to change here. This is only one thing, like we update position and then update collision. What we need to do is only update x-axis first, then update collision, then update y. So essentially it would be like x update collisions, check resolve collisions x, do the same thing again for y. That's too bad though, because now it takes like double the amount of time here. That does not feel good. I guess it would only be for... No, we have to do it for everything basically. I'm gonna try this and see. And then actually we don't do this, we actually do this now. Right. Okay. Right. I mean, we could like velocity, we could probably like acceleration. I mean, I guess it doesn't matter. I guess we do X, we split them up. I think we could do that. Those could be done just separately, but I guess we can split it up. Yeah, rotation we don't have, so this doesn't matter. Actually, that's gonna be done twice now. So I guess we'll just do it here, I guess. I don't know. You know what? I'm just gonna comment those out because they are not even, that doesn't even work right now. So it doesn't matter. Okay. So that was that. That was actually a lot easier than I thought it was gonna be. But now we do this twice. I mean, I guess technically, since we're splitting it up, the only thing we actually added was like entering the function, which takes basically no time, and then doing this switch here. We could even, like, let's say this was like a comp time. We could make two versions of the function, I guess. If this was comp time known. Yeah, if this is comp time known, and then this is like comp time switch, then I think you will get two versions where if it's X, we're gonna choose this code. If it's Y, we're gonna choose this code. I think so. That might be the way it's used anyway. But yeah, let's do it like that. Okay. Okay, so now first we do X, we update collections, which should just this could be an issue though, because this is really meant to only be called once. So let's say we get a bunch of collisions, we emit events. Essentially we just add that and set a collision. Yeah, I guess that's probably fine. But we also free this. What's happening here? Oh, that's just a list there. Yeah, that doesn't matter. And then we have quadri. Yeah, same thing there really. This one is returning this, which shouldn't be deinitialized. Okay. I was just checking what the issues could be there, but then when we resolve, actually, okay, that doesn't do anything. Number of collision events. Like, we should probably then end that. No, because we want to be able to get those events later, I think. But we end the frame. That... What? Populate tree with all entities. This doesn't make sense. Okay, I don't know what's happening here. I'm not gonna leave that alone for now. This one though, it resets the acceleration, which is fine. But I'm just like, when is it? Oh, here it's resetting the events and stuff. Okay. Right. Okay, and we resolve collisions. Okay, this is already kind of like, hey, we should start at 0 and go up to this. And then if we increase this, next time we call this is now the previous, this one. But then this one has increased, probably. I should probably check also that these are... I mean, what if we don't have any... I think if this turns out to be 0, then this will be an empty slice. So I think that's fine. Okay, I think this probably works. I don't really need to do anything, I don't think. But this is gonna be interesting to see if this actually does work. I don't think there's gonna be the update positions doesn't actually double now. I just realized as well. However, the collisions check does double, and that was the one that actually took the longest time as well. So yeah, but we'll see. It will probably not be exactly double, because once we've resolved the collisions for X, there's going to be way less maybe collisions for Y. I don't know. We'll see. Okay. Oh my god. I just realized I didn't show the code. Oh my god. Okay. Well, here we go. Okay. So before, it looked like this. Without these things. Okay. We update all positions. X and Y axis at the same time. Then we check for collisions. And we resolve collisions. Now we've divided it up in 2 steps, where we update positions for X only. We gather all collisions. We resolve the collisions for X, for the X axis. We update position for Y, and we gather new collisions potentially there, and we resolve for Y. Okay, I just want to check one more thing. Resolve axis. Actually, this could be comp time now as well, because this could be comp time, and you could be comp time, and then you are comp time. And you are comp time. This will, I think this will double double code, but it will increase. So we take up more memory, but like a slightly more memory, but it will increase efficiency when running the code. I hope, at least. I don't know if I have to add comp time here, or if it's gonna do it itself, or if this is even gonna make multiple functions. I don't actually know. I hope it will make multiple functions, but we'll see. Yes. So we reset X if the normal is... No, wait. If it's horizontal, right? No, if the normal is vertical, that means the surface is... The surface is horizontal. If the normal is vertical, that means the surface is horizontal. And then we should... Yeah. The surface is horizontal, we should reset Y. The surface is vertical, we should reset X. Yeah, I think that's correct. Okay, let's try it. Let's try if we broke everything, or if... It's gonna be a pain in the ass to test this, because it's like... It only happens very, very rarely. So... It could also be a fun bug left in the game, I guess. Okay. Watch this break everything now. Oh my god, what's happening? Yeah. Okay. What is going on? Come on. I can jump. I think it reset to the center of... Okay. If I press right, it goes down to the center of the... What the hell? Okay. Obviously, there is something going wrong here. Oh, hang on. We're still doing this. We shouldn't do this now. There we go. Okay. Yeah, because we're changing the velocity over here, so we don't do it over there. Okay, now we don't need you. Okay, I'll try this now. Oh, I'm slowly like walking into the ground now. Oh wow. Yeah, it definitely does not work yet. Okay. What the hell? Wait, what the hell's this? Why? Okay, I see what's going on here. Why did I change it? Why did I do this here? I don't really know what happened here. So if we're only doing X, we should correct X. Yes. This is the other way around. Oh my god. There we go. X should only, if we're dealing with X, X is the only one that should change. It's good to take a double take of your code sometimes, especially... Okay, so now that fixed that, but now it feels like I'm in quicksand or something. Okay, well, yeah, and then you can get stuck on a wall like this. I basically made the problem worse. Okay. So it could be that the velocity is the other way around. I'm just gonna try it. Even though I double checked this, it feels like this is wrong. But I will try this. The normal is vertical. That means it goes up or down. Yeah, that does. Yeah, it makes sense if that. Yeah, I don't know. We'll see. Yeah, see? I mean, for some reason it kind of works better. Now it feels like we're getting stuck on all these tiles, or we get stuck like at some interval. Like we get stuck now on all of the intermediate tiles or something like that. Okay. What is going on? I'm pretty sure this is a vertical check. Because this is 0, -1. If this is 0, 1 or 0, -1, they're gonna be times by each other. So it's gonna be like 0, 1 or 0, -1. And then added up, so that's 0 plus 1 or plus -1. So the answer should be 1 or -1 if it's vertical, right? And only 0 if it's not vertical. And then it's like we collided with, unless the normal is not what I think it is. Collision normal. Is the no, wait. Is the collision normal? Okay, the collision normal might actually be dependent on the velocity. Okay. In that case, should I even consider the normal here? I don't think I care about this, actually. I don't think I care about this. We just check the axis, because right now, I think I thought about this when I was thinking, like, we resolve the collisions at the same time. Like, we update position first, then resolve all collisions. Now it's updated. Now it's like divided in 2 steps. So if we get in here, we are certain that we actually have a collision. So I don't think we need to check these. I think we just say that, okay, well, if we get in here, we should reset the velocity at all times. Although that kind of speaks against the thing, because now it should reset the velocity more than it did before. Yeah. So now we're back to this. Essentially, every collision resets both X and Y. What the hell? Is there something wrong with the gathering collision then? X gets corrected here. The depth is also given, which is a scalar. So it's P plus negative depth back towards where we came from. But then we only take the X of that. And then Y should be updated. Then we shouldn't actually be colliding anymore. Do we want to add an epsilon here or something? To make sure that we are actually going out of collision. One second here. Let me check this, the grid algorithm here. Check intersection, check collision. Okay. So essentially depth, the collision depth has to be at least, it has to be positive. I mean, there could be some discrepancy. Maybe I'll just correct it with a little tiny bit of epsilon here. I don't really know how large this is gonna be. If it's like the smallest amount or something of a float. Also, I'm not sure if this is a good way of doing this. It does concern me that the x gets... We get collision events for x. And y. Okay, well... Okay, maybe that's not the issue. I don't know. Okay, I'm gonna refill my coffee. I'll be right back. All right. Okay, what is the issue? Was there anything wrong with the physics part or the position thing? Update X. X, we update the velocity and then the position X only. And Y, we do this. Yep. Because fortunately, X and Y were in separate vectors, so that's good. Yeah, and then this just gathers all the actual collisions, so this shouldn't really care about X or Y here. It just gathers all the collisions that we get. And then we resolve collisions. This is also like updated too. So we don't like resolve the same collisions twice. Actually, we should probably resolve these twice now, actually. We should, yeah. I mean, we don't need the switch at all, because there could be new collisions that we need to resolve. Yeah. Is there something wrong here? I'm pretty sure that's correct. I mean, we could also just do negative, reduce the complexity here a little bit. Also, right, because we are already calling these multiple times, so it already had like multiple time functionality. We're looping through this a number of times as well. I don't think that should be an issue though. It's just to increase precision in the collisions. We could try to just have one physics substep. It feels like that's not the issue though, but that will certainly speed up things, because the physics physics step will take like 1/8 of its previous time. Yeah, now it really feels like you're in like quicksand or some kind of mud or something. Okay, well that did not solve the issue. That's good and bad, because it's good because that was that was not a problem. It's bad because we still don't know what the problem is. And I can't really reason to why it's acting this way. So in this case, like in these situations, I usually end up logging out a bunch of collisions, checking what's happening. what we could do to start with, we could say resolving collisions. Because that should read like first it's from 0 to x and then x to y. I'm pretty sure this should be working already, but you never know. Yeah. I can see already here that it does well. What? Okay, let's do one more thing. Let's add the axis tag here. Because that looked weird actually. That did not look correct. And I don't really understand why, but I guess we'll see. Yeah, look at this. X from 0 to 0. Oh, okay. So if we have x 0 events, that makes sense, and then y 0 to 2. So that does make sense. That does make sense. Okay. If x was the 0 to 0, then that makes a lot of sense. But it seems like we always get y and never x. So y is... Okay. So why is x... Why is the x velocity changed? That is my question. So if we're dealing with x, if we have an x collision, then we reset. Oh, I'm stupid. This should be like this. Because this results in a vector 0, 1. Then effectively we're multiplying with that should reset. Okay, this was the issue all along. And then this does the same thing for the other. Okay. God damn it. Okay, I think we found the the culprit. Man. Yeah, the math is, for me, it's kind of hard. It's like, because it's hard to double check it. Here we go. Okay, now I'm not sure if this actually solves the issue, but hopefully, I guess, you know. Also, it's gonna be interesting, you know, if like corners, like all these edge cases and stuff. Like ledge grabs. We don't have ledge grabs, but okay, cool. So that now actually seems like it's working. Let's put this back to let's put, where is it? Let's put this back to 8. Okay. Cool. Now let's see. Now what? Now we say I want to remove this debug log. And I mean, yeah, I think with that, I'm gonna have to do a little bit of testing, but I think we solved the issue. It's gonna be annoying to test this though, because it wasn't really easy to trigger this. You know what we'll do? I will test this a little bit. But if this comes up again, of course, I'm gonna have to try and fix it again. But we could also just leave this here, and because during testing, I will surely run into this at some point. Yeah, that was a weird animation bug for the double jump. Alright. Whoa. Okay, if you come out from a double jump, if you attack while in a double jump, the sword and shield does not appear. Okay. Okay, but yeah. Yeah, cool. We solved this. We solved the bug. So let's tick this off. I mean, I hope we solved it. If it comes up again, I'm gonna notice and I'm gonna add this again. Alright. When attacking from double jump animation, sword and shield are not visible. Okay. Double jump animation bug. I'm not sure what is causing this. Sometimes it triggers late. Yeah, I'm not sure what's causing that, but I'll write it down. Okay, but short session today because I have some things going on, so I need to leave now. But yeah, that's gonna be it for this time. So thank you very much for watching. Have a nice day, and I'll see you later. Do you guys want to raid? Is the question, or should we skip it? Oh, you can see my whole thing. Well, whatever. Let's raid T2. Is this against the rules, by the way, to like stream another person's stream? Okay. See you later.